the period for both of these graphs, for tangent and cotangent, the period is pi. So that's a little bit different from what you have seen in the past, right? And as I had mentioned, it's kind of a little bit more memorizing that you're going to need to do on these, just because I'm going to give you a little bit of repetition over the course of today and the next couple of days to try to help you get these get these into the memory banks. But you're not going to have as much time with these as you did with your sine and cosine. Like, those are, sine and cosine are in your long-term memory now. Tangent and cotangent, we're not going to have that much time with them. All right, to help with thinking through how we are going to graph this and what points we are going to have, we're actually going to do a table of values to begin with. And what I want you to think about, so I would suggest you write this table, but you do not need to write this other part that I'm writing here. I'm going to draw basically the right-hand side of unit circle. And I want you to think about what the coordinates are at some particular points so that we can come up with what the tangent values are. So remember, tangent is y over x. So I want you to think about what the values are, what the coordinates are, I should say, at 0 degrees and at 45 degrees, which is equivalent to pi over 4, and at 90 degrees, which is equivalent to pi over 2. And then I also want to look at negative pi over 4 and negative pi over 2. So just watch and think about this. What are our coordinates at 0 degrees? What are the coordinates there? Sam, what are our coordinates at 0 degrees?
1, 0.
Yeah, 1, 0. Okay. And then at pi over 4, remember the hand trick if you need to. Fold down your middle finger. Think about what the coordinates are there. That's the one where the values are the same. So it's root 2 over 2 for both x and y. And that means for negative pi over 4, then we're at positive root 2 over 2 and then negative. All right, and then at 90 degrees, John, what's the coordinate up there at pi over 2?
0, 1.
Yep, there we go, 0, 1. And then down here at negative pi over 2, Talia? 0, negative 1. Awesome. Okay, so if we are going to fill in, do fill this in for me. If we're going to fill in our table here, so pi over 4 and then pi over 2. So at negative pi over 2, in other words, 270 degrees or negative 90 degrees, if we're looking at the tangent value, remember that's y over x. So that would be negative 1 over 0. Guys, what's that equal to?
Undefined.
Undefined, yes. Excellent. And then at negative pi over 4, that means we're looking at, remember, it's a numerator of the y over numerator of the x. So negative root 2 over positive root 2. CJ, what does that give us?
I do not.
So we're here at this coordinate, and we're going to do the numerator of the y. So negative root 2
Over 2.
over positive root 2, the numerator of the x. What does that simplify to become?
Just 2.
Oops, careful. It's the same number, top and bottom. So what does that give us?
When we cancel out that day.
Yeah. So what does that give us then?
1.
Yeah, so just negative 1. There you go. Excellent. Okay, at 0 degrees, Leah, at 0 degrees, if we do y over x, what does that give us? 0, okay. And then pi over 4, so now we're up here. Zach, what is that going to give us if we do numerator of the y over numerator of the x? Is just positive 1. Good. And then at pi over 2, Lucy, if we look here and we do y over x, we're going to have 1 over 0, so that's what? Undefined. Excellent. Okay, so this is what we're going to use to basically help us with our graph. For what it's worth, these are what I would consider the critical points that I'm going to expect you to show me. You're going to have to show me this also, but those 3 middle points are kind of going to be critical points that I'm going to expect to see on the graph. So the thing that's a little bit different about graphing the tangent graph is, if you notice, we're doing some of the graph to the left of the axis in the negative direction and some to the right. It's still a full period of pi. We're doing half of the graph going this way and then half of the graph going, so half to the left, half to the right. Okay, so we have let's see here, we have a negative pi over 4 and a negative pi over 2 and then the positive. And we are just drawing, as we did with our sine and cosine graphs, we're only going to draw one period, which in this case is a length of pi. So we're showing what's in between the asymptotes that we draw in. So our asymptotes, that's where it's undefined, that's where we're going to show asymptotes. So our asymptotes are at negative pi over 2 and at pi over 2. And then at 0, 0, so that's a critical point. And then if you notice, the other points that we're going to graph are at pi over 4, comma 1. So that would be here. And then negative pi over 4 and negative 1. So here's the deal. That looks like a straight line there, but this is really a curve. So be careful. My suggestion is that you kind of start from the origin and draw the curve going up, and then go back to the origin and draw the curve going down, just to kind of make sure you are getting a curve in there. If you try to go from lower left all the way up to positive right, some people have a good eye for getting that curve in there, others not so much. So I have to draw from the middle each direction. All right, so we've graphed those points, and then we've basically played connect the dots in terms of creating what that graph looks like. So the period is pi. We have half to the left, and then half of the pi to the right. So that adds together to give us the full pi. And this graph goes basically from bottom left, it rises to the right. Now, technically, we're not going to draw this in because we're only drawing the one period, but I want you to think about the fact, if you were to put this on a graphing calculator or on your computer, I would want you to realize, you know, we would have more asymptotes, and this graph continues, right, this way and this way. But we're just showing that one period, okay? So if you actually look at this on a graphing calculator, you'll kind of see that particular shape. I just didn't want you to be surprised if you're thinking it's just that one. All right, so that's for tangent. The period for cotangent is still pi. But if we were to go through and do the table, which we're not going to do, but if we were to do the table of values, what you would realize is that our asymptotes for the cotangent graph are at 0 and at pi. So a little bit different placement on the x-axis for this graph, okay? So if we're going to do the x-axis markers for this one, think about that. We're doing 1/4, and then 2/4, which is equivalent to pi over 2, and then 3/4, and then the 1 pi. All right, so those would be our x-axis markers. This is a cotangent graph. So similarly to the tangent graph, our middle goes right through the x-axis is at 0. So at pi over 2, we're going to be at 0. The difference on this one as well is that it goes the opposite direction. So for the cotangent graph, it's going to go up to the left, and then it's going to fall to the right. So some similarities, but some differences there too. The period is pi. They both have the asymptotes. the middle of the graph crosses through the y-axis, right? But the direction is different and the placement on the coordinate plane is different. So that's what you've got to kind of get into the memory banks. Okay? I think we're going to change some of these over here. But let's take a look at a negative tangent graph. We'll do that one first. So if you notice, I'm going down the page. So negative tangent, our asymptotes are going to be on either side of the x-axis, and we're going to label these x markers. So guys, what do you think is different for a negative tangent graph? It's flipped. Yeah, it's reflected, right? Exactly. So a negative tangent graph, actually, in terms of the direction that it's going to go, it looks like the direction of a cotangent graph, but we know it's a tangent graph because of the placement on the coordinate plane, right? If we're hugging either side of that y-axis, the origin there, in terms of where our asymptotes are, then we know it's a tangent graph. But in this case, it's just a negative tangent. Okay? So then that means our negative cotangent graph is going to be going the same direction as our positive tangent graph. Different location on the coordinate plane, but it'll go down to the left, up to the right. So for a negative cotangent, we're going to have asymptote at 0 and at pi, and we're going to, yes, you have to label these x-axis markers. And for a negative cotangent, we're still going to be here in the middle, but instead of going up to the left, we're going to go up to the right. And then let's go down to the left. Okay. I think I want to change one of these here. But I do need to show you kind of what changes with the sorry, give me a second. I want to change this number 5. Let's change this to let's just change this to a 2 tangent x. And then let's change this one, number 6. We're going to make this a 1/2 cotangent x. So, because I do need to talk to you a little bit about what changes with the look of the graph when we adjust the amplitude. All right, so this is a tangent. So where are my asymptotes? Kylie, where are my asymptotes for this 2 tangent x? Okay, there you go. Negative pi over 2 and pi over 2. So let's get our negative pi over 4 and positive pi over 4 in there also. Okay, so in terms of graphing the graph, we know we're going to go right through the origin. What do you think the 2 tells us? What is that going to adjust? So that critical point, instead of being at, for pi over 4, instead of it being at 1, we're going to go up to 2. And then at this negative pi over 4, we're going to go down to negative 2. So we do still have a curve here, so you do still need to make sure that you're showing a curve. But I want you to think about it a little bit. It's as if someone's taking the ends that's from top and bottom and kind of stretching or pulling on it so that it's not as curvy, right? It's going to take longer to approach those asymptotes. So that's what changes with the look of the graph. So if we were to compare this with the parent graph, we would say it's not quite as curvy. It's taking longer to approach the asymptotes. Okay? So that's what happens with an amplitude that's greater than 1. If it's a half, like this, it's going to make it a little more curvy than the parent graph. And I'll show you kind of something else that tends to happen here also. All right, cotangent decks. Owen, where are the asymptotes?
0 and pi.
There you go, good. 0 and pi. And let's label the rest of these x-axis markers. So pi over 4, pi over 2, 3 pi over 4. So that 1/2, we're still going to be at pi over 2, we're here at 0. But now at pi over 4, we're only going up 1/2. And at 3 pi over 4, we're only going down a negative 1/2. And so if you think about it, it makes the curve. So if you have an amplitude that's between 0 and 1, it's a little more curvy, and it actually kind of flattens out a little bit more along in here. And it approaches the asymptotes a little bit quicker, is what happens with that visually. Okay? All right. I know there was some repetition there, but that's to help you kind of get these placements on the coordinate plane for that. All right, questions though on either of those? Okay. Now we need to talk secant and cosecant. And I think I'm going to adjust this one, and we'll see. I'm probably not even going to do this last one, but we'll see. Let's change this to a 2 cosecant of 3x. So that's on the next page, number 9, because I want to refresh your memory on period changes. So we'll see. We may not even do number 10. But I definitely want to talk you through the process of thinking about what we've got to do for cosecant and secant graphs. So we're going to start with the cosecant. We know that cosecant is the reciprocal of sine. So actually, we're going to use the sine curve, the sine graph, as kind of as a model or part of the process in actually creating this graph. So let me go ahead and mark. Nothing else has changed here, so we know we want to go up 1 and down 1, and these are going to be our typical x-axis markers. Sorry, I got ahead of myself. I don't know if I mentioned this. For the period, because these are the reciprocal functions for sine and cosine, for secant and cosecant, the period is 2 pi, just like with our sine and cosine. So you got to keep that in mind. So that's why I'm drawing these basic x-axis markers of pi over 2, pi, 3 pi over 2, 2 pi. Okay? All right. This is not considered part of the graph, but in order to figure out and create the graph, we actually want to use the basic curve for our sine graph. So my suggestion for you is that you either lightly draw it in or kind of draw a dotted line. I'm going to do a highlighter here, just to help us see or visualize where the sine graph would be. okay? All right, we know these are reciprocals. Sine and cosecant are reciprocals of each other. So if you think about it, if we look at these y values, if we have a y value of 0, and we take the reciprocal of that, then the reciprocal would be 1 over 0, which we know does not exist or is undefined. So what that's telling us is that that's where we have asymptotes. So part of what you're going to graph on a cosecant graph is you're going to think about where the sine curve is crossing the x-axis, and that's where you're going to draw asymptotes. So we have asymptotes for this cosecant graph at 0 and at pi and at 2 pi. So that is part of what you have to graph in order to graph these. So asymptotes at 0, at pi, at 2 pi. And then 2 critical points that you're going to draw in, and I didn't do a very good job of drawing it here, but one of those critical points is at 1. If I ask you to take the reciprocal of 1, then we flip 1 over 1, which still just gives us 1. So this point is on both our sine graph and our cosecant graph. Okay? From here, I need you to think about, I want you to visualize or kind of think about this shape and what the points would be here, right? What the y coordinates would be for these particular points along this curve that I've highlighted there in the green, that shape. Okay, so think about what some of those points would be, what those y values would be. It would be like 1/4, 1/3, 1/2, right? If we take the reciprocal of 1/4, we get 4. If we take the reciprocal of 1/3, we get 3. If we take the reciprocal of 1/2, we get 2. So visually, what you can kind of think of is where these particular points are along this curve. If we use that as a guide and we basically think about flipping or reflecting over that line y equals 1, then that gives us what our graph is going to look like. So these points end up creating a curve. Let me make this darker. Let me go in this color, in the dark and not the highlight. If we flip or reciprocate all of those points, we basically get the shape of this cup, but then we have to remember to draw the arrows showing that this is, we've got asymptotes that are going towards that. So similarly here, if we look at these particular points and we think about taking the reciprocal of those and trying to draw in those points, we basically get a cup that reflects over that line y equals -1, Ireland, to create that shape along with the arrows at the end to say we know this, it's not crossing, but it's going to keep going closer and closer and closer to those asymptotes. Okay? So that's what a basic cosecant graph looks like. You're going to show me the asymptotes, and you're going to show me then basically the critical point and then the flip of the curve. Okay? Comments or questions on that graph? All right, let's look at this 2 cosecant of 3x. So we need to adjust the period. So let's review how we do that. And then 1, 2, and we're going down 1, 2. Okay. So remember, to adjust the period, we're doing 2 pi over b. So in this case, that's going to be 2 pi over 3. So remember, that's our last hash mark. So that's this here, right? From that point, I want to multiply that by 1/2. So my 2's would divide out, and I get pi over 3. So that's my middle hash mark. If I multiply by a half again, I get pi over 6. And then if I multiply by 3 over 1, I get 3 pi over 6, which is equivalent to pi over 2. Okay, are we good with that period change there? 2 pi over b, remember, and then half multiplied by 3. Okay. We also have the 2 out front, so that means when I'm graphing my sine curve to kind of use as a guide, I'm going to go up to 2 instead of just 1. So my asymptotes are still going to be, all right, Ireland, my asymptotes are going to be at 0, and then at this case it's at pi over 3 and 2 pi over 3. And then this point, and we reflect the shape of that cup going up, and this point, and we reflect the shape of that cup going down. Okay. All right, that's cosecant. We're going to do similar process for secant graph. For a secant graph, I just need you to think about it, and I need you to realize we started a different place where the cosine graph looks differently, so the graph is going to look very different also. So I'll talk to you a little bit about that also. Okay, so let's label stuff to begin with. Let's just do a basic 1 and -1. All right, so I want to draw in a cosine curve, which that one starts high and comes low, and then comes back around. Okay, so to graph the secant, we are looking at where this graph is crossing at 0. So our asymptotes for this graph are here and here, so at pi over 2 and at 3 pi over 2. Okay, that middle section between the two asymptotes, it's pretty easy here to realize, okay, I'm drawing that critical point and then reflecting that cup. On the ends, some people have a little bit of difficulty with this. All I really have to see is you graph this portion of the graph, but for some of you, if you prefer to continue this graph and actually draw in that full curve just to make sure that you're drawing that correctly, because some people just kind of mess up with drawing that correctly, because it looks weird, right? That we're starting at 0 and we're only drawing part of that curve. So if you feel like you want or need to finish that curve to help with drawing the shape, then please do that. Okay. So looks a little bit different. Only 2 asymptotes here for the period that we are using, right? And then we have just the portions of each of those curves. I'm not even going to bother with this one. I think you guys are good to go, and you're going to have some practice with this. There's worksheets up there, and I probably should have told you to grab those ahead of time, and I didn't. So your classwork / homework, you've got about 15 minutes now that you can work on this. Your classwork / homework is in the packet. It's pages 20 and 21. But then also this worksheet, so if you want to come grab that, I'll start passing a few of these out also. But I need you to notice I've made some changes on the bottom of this worksheet, so come grab. You don't have to worry about doing this part. You're just doing these 4 problems here, 11 and 12 and 13 and 14. Hold on just a second. I want to make sure you get this, Dina. So notice on 11, 12, 13, and 14, you're doing 11 and 12 as they are, 13 and 14, change those. Look at 13, it says 5/2 cotangent x. And for 14, it says -3 cotangent x. So please make sure you make those changes on that worksheet. Okay? So you're doing this worksheet, and in the packet, it's pages 20 and 21. You guys are always asking me, what did you call this assignment? And I know it's a pain in the neck looking on Canvas. So that's what you're looking for, is a classwork / homework graphing secant, cosecant, and tangent and cotangent. Okay?